Hello everyone, I am Anushka Srivastav. Welcome back to my channel. So this is my ninth video on my data science playlist which is based on regression modeling. So let's see what are the topics that we are going to discuss today. Today we are starting with regression modeling. So what do we mean by regression modeling? Regression modeling is a statistical technique used in data science to establish a relationship between a dependent variable and one or more independent variable. The goal of regression modeling is to create a mathematical model that can predict the value of dependent variable based on the value of independent variable. Key concepts in regression modeling are as follows. Number one, dependent variable, that is also known as target, the variable being predicted or explained. Number two, independent variable that potentially influence or predict the dependent variable. Number three, model coefficient, numerical value that represent the strength and direction of the relationship between each independent variable and dependent variable is known as model coefficient. Let's talk about the applications of regression modeling. Number one, predicting continuous outcomes. Regression modeling is commonly used to predict continuous outcomes such as stock prices, temperatures, and energy consumption. Number two, forecasting. Regression modeling is commonly used for forecasting future values of a time series. Number three, recommendation system. Regression modeling is commonly used to build recommendation system that suggest products or service based on users' behavior. Number four, risk analysis. Regression modeling is commonly used to analyze the risk of a particular event outcome. Number five, optimization. Regression modeling is commonly used to optimize business process and improve efficiency. Let's discuss the type of regression models. Number one, linear regression. This is the simplest form, modeling the relationship between a dependent variable and one or more independent variable using a straight line. Multiple linear regression. This model extends simpler linear regression by incorporating multiple independent variables to predict a dependent variable. Number second, polynomial regression. This model uses a polynomial equation to fit the data, allowing for more complex relationship between the independent and dependent variable. It's useful when relationship isn't strictly linear. Number three is logistic regression. Although it's named regression, logistic regression is actually a classification model. It's used to predict the probability of binary outcome, example 0 or 1, yes or no. Number four, bridge regression. This model is used to address the issue of multicollinearity where independent variables are highly correlated. It adds aplenty terms to the regression equation to reduce the impact of these correlated variables. Number five, lasso regression. Similar to ridge regression, lasso regression also addresses multicollinearity. However, it performs feature selection by shrinking the coefficient and less important variable towards zero. Number six is random forest regression. This model builds multiple decision trees and combines their prediction to improve accuracy. It's robust to overfitting and can handle complex relationships in data. How it works? Steps are as follows. Number one, data preparation. Gather and clean your data to ensure it's suitable for analysis. Number two, model selection. Close the appropriate regression model based on the nature of the data and the relationship you expect. Number three, model training. Use algorithms to find the best fitting models coefficient that minimize the error between predicted and actual value. Number four, model evaluation. Assess the model's performance using metrics like R squared, MSE, and MAE. Prediction. Use the trained model to make predictions for new data points. Let's demonstrate estimation model evaluation using Python. Step number one, import the libraries. Step number two, load datasets. For this example, we'll create a synthetic dataset. Let's create a simple linear relationship with some noise. Step number three is to split the data. Step number four, train the data model. Step number five, make prediction. Step six, evaluate the model. Step number 7 is to visualize the results. Demonstrate stepwise regression using Python. Stepwise regression is a technique for feature selections that iteratively adds or removes predictors based on their statistical significance in explaining the dependent variable. It is commonly used to identify the most important feature in regression modeling. Steps are as follows. Step number 1, import libraries. Load the Boston housing dataset. Step number 2, define functions for stepwise regression. Step number 3, perform stepwise regression. Step number 4, evaluate the final model. So here I am ending my lecture. I hope all your concepts are clear. See you in the next video. Thank you.